Okay, in lesson 4, we're now ready to start doing the actual programming. As you'll know, this is where we left off last time. You'll see some of the parts over here suppressed, and you'll see a bunch of different sheets. The reason for that is CAMWorks Nesting actually creates configurations of an assembly. And as you can see here, it calls out the material thickness and the quantities needed for each one. So you know how many of each sheet you need, and then the material thicknesses. Now, if we were building 3 or 4 of these these entire section weldments in the shop, then we would just take all of these programs we write and we would just double them or triple them depending upon how many we need. So if we needed 4 sections, we would do 4 of this sheet, 4 of this sheet, 4 of this sheet. We would do 12 of the sheet, 4 and 4. So they're all spaced out here, and they're already added to CAMWorks because we had CAMWorks turned on while we did the nesting. So if I go over to the CAMWorks tab, you'll see here it already has all the parts selected. It already has the sheet laid out. As you can see here, it already knows the boundary of it. Now, one thing we do have to do to make our program come out right with the Z-depths is we will come down here to the stock manager, and you can either right click and do edit definition, or you can simply double click on it. It'll open up, and then I change this to the thickness of the material I'm working on. So we'll do 3/16, and you'll notice 3/16 goes to the back side of the material, not enveloping it. So we'll go ahead and reverse direction. That way, when we do our depths, all our Z depths for 3/16 will be 0.1875. It makes it easier to find it in the program to remove it. So we have that completed. Now we'll go up to the machine area up here, and again you can right click and do edit definition, or double click on it. It brings up our window here. We'll go to posting, and then this is where I start laying out what the name of the program is going to be. So there's several different ways you can do this. I generally go incline section sheet 1, and then I change this to the tech table I'm going to use, which is 11870 for 3/16. We'll change it to oxygen, and then I put the thickness in here, and I do this because this is what will show up in the program here in a little while. So we'll hit OK, and then again, for safety, I always go ahead and hit save, just so that way everything's saved. From here, we'll go to CAMWorks tab, and we'll just do extract machinable features. Now, we have a technology database that's set up for a majority of the parts that we run. The lead-in, lead-out's right, the depth is right, but we'll go ahead and find all of these features here. Now, the next step we'll do is we'll do generate operation plan. And if you don't see these in your menu up here, you can always go down to setup, right click, and do generate operation plan. And that'll go ahead and grab all the tools. And then we'll right click again, we'll do generate toolpath. And now as we look at this, I zoom in here, you'll see that it has a depth set and has a lead in and lead out. This is all stuff that we have built in the technology database. If I want to edit any of these or make adjustments to them, I can just double click on them. We'll get a menu that comes up here. Here's all our feeds and speed information. For steel, we just always leave them at this number here. If we're doing stainless or aluminum, then we would set this speed to whatever the technology database has it set at, say 35 inches a minute as an example, and then the lead in would come down to like 2 inches a minute, so that way when it pierces in the sheet and starts, it'll start out slow and then ramp into the part, so that way we get a clean cut every time. Now, there are 2 areas we generally want to check. We go to feature options here. We want to make sure that the machining depth is still set at 3/16. Sometimes it'll change depending upon the material type, so we'll go ahead and just do a thickness here. I'll type in 0.1875, and then that'll make sure the machining depth is set there. The second area to look at is actually the lead-in, lead-out area. Now, by default, again, this pulled from the technology database, the stuff that we've been actually using and setting up and customizing. But if you needed to change it, let's say you're doing some artwork and you need to have a smaller lead-in, you can change the numbers here on the arc or the lead-in amount or the angle. And then when you're done, you always have to hit apply lead in, lead out to all, hit OK, and then the toolpath updates. Now you could go ahead and do that for all of these. You can see that these are all pretty much placed. Generally, when we do our big components like this, I just program it, leave it, and call it good. So the last thing that we'll do here is we'll go ahead and post this out. One thing to note, when you do assembly machining like we are right now with all the parts, 0 will always end up in the lower left-hand corner where the actual sheet size is here on the screen. If you're doing part programming, then you have to set 0. But for now, for most of the majority of the things we do, we'll just right-click, and then we'll go to post-process. We go to post-process, we'll go ahead and pick the location we want to go. This would be generally in your job folder, so like 15145, laser, programs. We'll go down to training, lessons. We'll put it in lesson 3. And then I would name this, like if in lesson 3, let's say we're doing 3/16. So I would create a folder called 1875. And in here, I would do 1 space dash space incline section sheet 1, and then from there we'll go ahead and hit save. Okay, so once we hit OK, generally I go ahead and hit the fast forward button. It just creates the code. When it's done here, you can hit OK. And then it'll open up in an editing software, and you can see that we now have our incline section sheet 1. Here's our material thickness, and then down here we can start changing the code. Now, one thing I generally always do is I'll go to my feed rate here, the first one. This controls how fast it'll move when it's actually between cuts. I generally run that about 800. It's always good to go a little bit slower than a little bit faster because it saves a little wear and tear on the bearings on our machine. You'll notice that we have a 11870 here. That's the material thickness that we run from. And then at this point, we'll go ahead and we'll start getting rid of all the Z values, and we'll start getting rid of all these feed rates. And the reason that we do that is the tech table actually has the feed rate control, the height, the Z, all that stuff is done in there. So we don't really need these here. There are times when we do custom parts where we will need these. That's why they're not removed from our post processor. But it's real easy to go ahead and remove it. So we'll just go ahead and do a replace. And we want to replace all the F90s with nothing. So we'll do replace all. There's 9 of them here. And then we'll come back and we'll replace all the F1200s, which you can see here we changed this one, so this one will be ignored, but all the other ones below it, you'll see there's 8 of those. There should always be one less F1200 than the other feed rates, and that's because we changed one up here. So the last thing we'll do is we'll go ahead and change Z0. We'll get rid of all those. And then I just do a quick search for anything else that's a Z, because sometimes you'll have different Z depths. And then we should have all of our feed rates and all of our Z's gone from the program. Now the last thing we do at the end of the program is we change this to a Q27, G71. And what that does is at the end of the program, then it'll bring the head all the way up to the home position, and G71 will move the head back to the middle of the table. That gets it out of the way from wherever it's at on the cut, so it's easy to change the sheets. Once we have this, we just go ahead and hit save. And that program is done. So the next step is we'll go back, we'll activate this configuration. You can see that we have it over here. Now, you'll notice I changed the configuration in the SOLIDWORKS Configuration Manager. That is not the easiest way to change it. What I would do is, if I go back to this one, if I go to CAMWorks here, we have all of the configurations right here from CAMWorks. It is better to change it in the CAMWorks Feature Manager. Just double click on it here, and it'll ask, do you want to change to the correct SOLIDWORKS configuration? You hit yes, and it'll automatically update. And when it does that, now you have all of your information in here with the correct parts loaded and all that fun stuff. So from here, it's the exact same process we just went through, and we just work all the way through the table till we get done with this, and then we start all over on the next group of parts.